Hi everyone. In this video, we are going to solve a problem. The problem name is same tree and the question number is 100. First of all, we will discuss about this problem. After that, we will see the logic, how we can solve this. And after that, we are going to implement our logic. So let's quickly see what this problem say. Given the root of two binary tree P and Q. So let's say this is a P and this is a Q. We have two binary tree and the root is P and Q. Fine. Write a function to check if they are same or not. Now we have to check these two trees are same or not. And when we can say our two trees are same, two binary trees are considered the same if they have structurally identical and the nodes have the same value. So we can say this two binary tree will be same only and only when they have a same value on each node and they have same number of nodes on the left and right side. So guys, you can see that here we have a value 1, right, on the root node, and here also 1. So far these three are same, right? Now we can say that this one root node has a one left node, right, that is 2, and this also has a one left node that is value 2. So still we can say these two trees are same. Now this has one right node that is 3, and this also has one right node that is 3. So now still we can say these trees are same, right? But there is no more node left, means 2 doesn't point to any left and right, 3 doesn't point to any left and right. So we can say P and Q tree are same. So we are going to return true. I hope you understood this. Here we are having a same value on each node. Root node has 1 1. It has one left node. It also has one left node. It has one right node. It also has one right node, and the value is also same. So we can say these two trees are same and we are going to return true. I hope you understood this. Let's move to the second example and see why they are false. So here we are getting answer false. So why it is? You can see we have root node that is 1, right? We have root node that value is 1. So far so good. Now it has one left node that is value 2, but it does not have any left node. So we can say this is not going to be same. This P and Q trees are not same to each other. So we can return false. Now let's move to the third example and understand from there. So here guys we have a one root, right? So 1 and 1 same, so far so good. After that it has one left node that is 2, and it doesn't have a left node that is 2. It has a right node that value is 2, but it does not have any left node that has a value 2. So we can say this is going to be false. These are not same, so we can return false. I hope you understood this and see the constraint as well. Node value is not going to be greater than 10 raised to power 4 and not going to be less than minus 10 raised to power 4. Alright, so we can have at max 0 to 100 tree node in our tree. So now let's quickly move to the logic and see how we can solve this particular problem. So guys, I'm going to write here logic. Fine. And what will be the logic? So let's consider this example. So I'm going to say, let me remove all these things. So I'm going to take this example only 1, 2, 3. Okay. So what we are going to do? We are going to check recursively. First of all, we are going to say if root exists, if we can say if P and Q both exist, that means both exist, then only we can say it is true. Either there should be node on both sides, either there should not be any node on any side, then only gonna true. So we can say if P and Q both are exist, then we have to check one thing, that value are same or not, right? Now we have to check whether value is same or not. If value is not gonna same, like here they both have left node but the value is not same, 2 and here is 1, so we can return a false. So we can say again check condition, if P dot val is equal to Q dot val. So we can write here in not equal to, because if it is not equal to, we can directly return false. So we can say return false. Fine. But guys, if it is equal, then what we can do? We can call it recursively. We can now say call the same function. I'm going to take a function name, let's say sol. So call the sol function again for P dot left, for Q dot left. One time I'm calling this for left side. So now it will gonna take this left side and this also gonna left side. So we are going to call this left side one time, and after that we are going to call same function for right side. I will tell you how it works. I'm going to say P dot right and Q dot right. All right. Once we call this, you know guys, it is going to call it recursively, but only when their node exists. If there is no node, then it's not going to call. It will come in a else condition. So let's write here else part as well. So I'm going to write here else. In else part, we are going to check one thing. So let's take else if. So I'm going to say else if, and here we are going to say if P or Q, that means any of the node exist, P or Q will be returned true. Only one side we have a node, right? Because we have checked already, if both the side we have node, then it will not go in this elif condition. But if it's going in that condition, then we have to going to check if there any node exists, P exists or Q exists, then we can say return false, because we don't want a one node on a single side. After that we are going to say else return true. That means there is no node exist on the both side, then also it is going to be true, right? So else return true. I hope you understood this. This is simple logic. Now let's quickly see what I mean by writing these two function again. See guys, let me take a different color and let me remove all these things. Alright, so we have these two example. I'm going to consider these two example. Here first of all we will say P and Q both exist, right? Now we have to check the value. Both are same, 1 and 1. Fine, 1 and 1 are same. Now guys, we are going to say, okay, so far our tree is good. So we are not going to return false, but we are going to check recursively. So it will goes left side first of all. So okay, we are going to say left side. After that we are going to move to this node, right? So it will say both the side we have node. Yes, 2 and 2 we have node. After that we are going to say both the value are same. Yes, value are same. It will gonna move to again left side. So it will go 2 left and 2 left. But guys, here you can see that once it go, it will come here and it will see that P and Q exist. No, both the node don't have any left node. And so it will come in elif condition. It will say, does any node exist on any side? No, still we can say on the both the side we don't have any node on left side. Then it will come in else condition and it will return true. So it is finally gonna return here from true. So it will say true, fine. And this is also gonna say true, fine. But let me write on one side because we are calling on one side. So we can say it is gonna return true so far on this left node, right? Now it will come to the right node. We can say we are calling right side. So still here you can see that both have same node, 3 and 3, and so they are also gonna return true. Now this one will have a value in this true value and this true value, and the end of this. Both the sides should give us a true. So here we can say return, let me consider it left or L, R, return L and R. Means both should be true, otherwise return false. It is not the case that one side left side you are having a same tree, but right side it is not same. So both the sides we have a same tree, then only we can return true. So this root node will see whether I'm getting a true value from left side, I'm getting a true value on right side. Okay, that means my left and right nodes are same. So we can say my this tree will be same. I hope you understood this. If you still not, let's move to the implementation part and see how we can write this particular logic, and definitely you will understand from there. So here guys, first of all, what we are going to do, we are going to check if P and Q both are exist, that means we have to check their value. So we can say if P dot val is equal to Q dot val, that means they are same. But if it is not equal, then we can return false directly, right? So we can say return false. Now guys, once we have checked the value, that means they are same, then we can call it two times. So we can say self dot is same tree, fine. And here we are going to pass for left side, P dot left, Q dot left. And again we will pass for right side. So let me write here right side, self dot is same tree, P dot right and Q dot right. That is. So now guys, we are going to return true only when these two function will give us a true, right? It's not like one function giving true, one function false to return true. So we are going to say two variable here, A, or we can say L, and here we are going to say R. And we can return like this, return L and R, right? But we can also do directly. Let me remove this all. We can also say return this only. So let me show you how. So we can say directly return self dot is same tree for left side and for right side, right? We can do like this, right? Now guys, once we have done this, we are going to say now check in elif condition, elif P or Q, that means only one node exit on any sides, then return false. False. After that, we are going to say else, that means no node exit on the both sides, so we can say return true. I hope you understood this, guys. So let's quickly run this code and see whether it's working fine or not. You can see guys, both the three test cases are passed. So let me try to submit this code. And here we go guys. You can see that it's successfully accepted. So this was the easy problem. I believe you must understood this problem. If you still have any kind of doubt, you can ask in the comment section. I'm always there to help you. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.